The third type of addition reaction is free radical addition. Free radical addition or radical addition reaction. You can say F, free radical addition reaction. FAR reaction, or again addition with a radical, we use R instead of F, we use the R, AR type of reaction. That is, radical is attacking as a first step in the reaction. In fact, second step also radical only involved, but the classification is addition reaction classified based on first attack, because two species are attacking. First attacking species is the criteria. Here the radical is attacking. So the reaction is here shown as a ethylene when added with HBr in presence of hydrogen peroxide or some peroxide, or some any peroxide you can take. Some peroxide must be there. In presence of a peroxide, the H adds one side, you will get the H3, other side Br is added, that is ethyl bromide is formed. Ethyl bromide, HBr addition to ethylene in presence of a peroxide, the mechanism follows the free radical addition reaction. If this is not there, imagine the hydrogen peroxide is not there, it will become an electrophilic addition reaction. As I said, the ethylene is rich, so H plus Br minus when allows to attack, or without opening HBr comes also because of the electron richness, the HBr undergoes a electromeric, inductomeric effect and becomes into delta plus and delta minus, totally will become into plus and minus, and first plus attacks. That is what a electrophilic addition. But here the total condition is different. First, the hydrogen peroxide undergoes a breakage. The OO bond is called peroxy bond. Both the oxygens are equally pulling the bond, so therefore even type of breakage, or it is also called as homolytic fission takes place, that leads to give the two OH dots. The dot means a free radical. Call it as a hydroxy free radical, not hydroxide. IDE shows anion. This is not anion, this is center breakage. So this side one electron, that side one electron, leads to give the OH2 dots, that is called hydroxy free radical. Hydroxy free radical. When water ionizes, you get a OH minus, this is different, OH dot. Now one of this OH dot react with this HBr. Before HBr attacks an alkene, the OH dot reacts with HBr. Again HBr undergoes a homolytic fission. This is called induction, or this is inducing the bond. So this OH dot induces the HBr to undergo homolytic fission, because if H plus comes it cannot make, Br minus comes it cannot make, therefore it breaks homolytically, get one of the species with one electron. So it has a chance of doing the two types. OH can react with H, forms H2O, releases the Br with a dot, or you have another chance, OH plus Br will become into a HOBr plus the H dot may be released. But it is found that the potential energy of these two is more than the potential energy of water and the Br dot. So thermodynamically we are saying that this process is likely to be taken, and this is not taking place. So we accept the first step, that is when OH dot reacts with HBr, forms water and the Br dot. This is what now the first attacking species. So ethylene first reacts with what? The Br dot. That you call it as a bromine free radical. Don't say Br minus is called bromide anion. Br plus is also available, call it as a bromonium ion. This is bromine with one electron is called bromine free radical. This free radical is having one electron, therefore even the pi bond undergoes a breakage now. homolytically, so that each side one electron will come, and this electron and the one electron of the bromine will make a bond formation. What about this electron? This electron goes to this carbon. See, I am using a arrow having only one sided hook is there. This is called a fish hook arrow that shows movement of a one single electron. This electron goes to the CH2, that is carbon will become dot. So, this electron and this electron makes a bond between the CH2Br. So, this is called step 1. So, what all you found that is hydrogen peroxide breaking, HBr breaking is not step 1 now. The step 1 is the reagent that attacks on the compound is first step, it is free radical attacking. So, one side the bond is formed, that is CH2 plus a Br is formed, right. The other side now CH2 will get one electron. This is called as intermediate species. Again, this is important because the free radical is on the carbon. This carbon free radical has two major important issues. One is how best it is stable, how far it is stable. The more the stable, fastly reaction formed are favorable to such type of the formation. If it is not that much stable, even after the formation it may undergo some rearrangement and so on. These are the two issues we are going to find in a complicated reactions later. But right now, so one side Br is added, the other side we know that H is going to be added. But where is H now? The H is with OH in the form of water. So, therefore, right now what happens? The water undergoes a breakage. This is the water, same water, because we know the major reaction is HBr addition. We accepted the H is formed and found also the ethyl bromide is formed. So, bromine is already addition is over. Now, the due is H dot, but H dot is now in the form of water. It also undergoes homolytic fission. The H dot alone is used on the addition of this one. So, okay, it attacks here using that electron, a bond is formed. So, therefore, one side the H, one side the Br is added. So, let us write otherwise this side H, that side Br is added. So, the two steps are there. Second step happens to be the H dot addition. First step happens to be addition of the Br dot attacking. So, therefore, if somebody asks what is the attacking species, the reagent is HBr, no doubt. HBr is the reagent, ethylene is the substrate or the compound which is undergoing reactant, reagent. The hydrogen peroxide is called here a catalyst because after the reaction this OH dot is released, isn't it? H dot is added. The OH dot once again join with another OH dot, similar reaction will releases the OH dot, isn't it? Two such OH dots forms into hydrogen peroxide. So, therefore, hydrogen peroxide used in the reaction is not totally consumed at all, isn't it? It is regenerated back. So, the role of hydrogen peroxide we call it is a catalyzed reaction. So, in presence of a catalyst peroxide, the HBr breaks into dot dot. So, first Br dot is attacking, therefore, I call it as a attacking species, followed by the H dot, that means H dot temporarily takes a rest with the OH dot and then comes into the picture in the second step, then the addition is completed. So, here also two species we are adding, first Br dot, then intermediate species after the step 1, then H dot is added, then the final product is formed, ethyl bromide is formed.